All right, let's get started. Hi, Trevor. All right, let's do this. It's genuinely upsetting that we still have Wi-Fi issues all the time. It drives me absolutely crazy. My Spotify app that shuts the music on and off, I rewrote the whole thing, got rid of my bugs. As far as I know, everything's working great until the Wi-Fi goes out. Then it's not going to work on time. And I have a lot of demos today. Let's just hope that it survives the next 38 minutes. So let's get some slides down first. Oh, the announcement. I have to not forget to say this. This doesn't apply to too many of you, but I want to make sure I say it in lecture so it's not 100 individual questions. For project part 1, grades are out, first of all. Hey, and we do have some internet here. For objective 2, I don't know why there's so much confusion on this. The objective is literally named build an app, right? I thought that was very clear. Build an app. The first sentence, build an app. You have full freedom in what you build. You're making an app. If you took my code from the homework and that was your app, you did not build an app, and you get a 1 for that objective. It wasn't too many, but an upsetting number, probably 10 to 15, somewhere in there. Students just took my code. Some made very small changes, which I'm fine if you use that as a template and you use that as a starting point. A lot of you did that and actually changed it and made it your own. That was fine. You would get 2 or 3 for that, depending on everything else. But if you just use that and changed very little to it, my criteria, which I think were very, very loose, was if the page is unrecognizable from the homework code, then you're good. Or if it is recognizable, but you change something in the HTML, something in the CSS, and something in the JavaScript, then I'm like, you know what, at least they made some changes, made it a little bit their own. But some students just changed like a few characters in the HTML. The CSS and JavaScript were identical. You didn't build your own thing. So if you got a 1 for that, don't complain to the TAs. That was my, I guess, decree overgrading that said you have to build this. I had this question before the deadline from a few students, and I'm like, why would anybody even ask this? It says build an app. You can't just steal mine and host mine. Build an app doesn't say steal code from your professor. That was what you were expected to do on the homework, but when it's the project, you're building your own project. I don't know, but I want to make sure I say that. You can still come and complain to me if you want to argue and vent about it. I'll listen to you, but I'm not going to change your grade. And don't bug the TAs about it, please. The TAs already got a lot of requests for that one, and they're going to say that was Jesse's decision. Take it up with him. Oh, not yet. We're still here. HTML injection. So we don't have too many slides today, 15 slides, but we have some demos to do, and I want to get to those demos. So let's hope the Wi-Fi holds up and do these demos. All right, injection attacks. One of our first real security things. We've talked about some security things before, but this is the first one that I'm going to really take an in-depth look on. We talked about SQL injection. We talked about cross-site request, or no, we didn't. That's Wednesday. We talked about disabling packet MIME type sniffing. Those are both definitely security things, but I didn't go too far in depth. I just said, here's how you protect against them. But let's go do a deep dive in HTML injection attacks with demos and all. So what is an HTML injection attack? Well, before, we didn't have any. There was no HTML injection attacks. We were hosting static pages, what I like to call poster sites. It's like pinning up a poster on the internet. And that's what we did in homework 1 and project part 1 also. And the user had no control. They were just consuming information. You had full control over all of the content that your server served. Starting with homework 2, that is no longer the case. You are taking user-submitted content, which is messages and chat at this point, and hosting that for all of your users. So any user can submit text, and then you're taking that text, storing it in your database, which isn't too concerning unless you're open to SQL injection. But then you're taking that out of your database and sending it to every user. So if an attacker can get something that can attack other people in that chat, you're going to send it to all of your users, and everyone is going to be attacked. This gets scary. This is dangerous, very dangerous stuff. So never trust your users. You don't know what your users are going to put in that chat. You're hoping they're just going to talk about their day and video games and college and stuff. They're not. Do not trust them. There's going to be at least one user out there who abuses this and attacks any vulnerability that you expose on your web app. So never trust your users. If I said this enough yet this semester, I don't think so. Seriously, never, ever, ever trust your users. Do not trust your users. If you're ever writing a web app and there's a vulnerability and you're like, my users will never exploit that. No, they will. Somebody will. Eventually, over time, somebody's going to. And this sounds bad. I've talked about this last week briefly, but now I have a slide to help me out. Don't trust your users, and you might be tempted, okay, I'm going to trust my users. They're all going to act in good faith, bless you. And yeah, your users, they're your users. You like them. And maybe that's true for most of them. But especially if they're paying customers. Like, you want to trust your paying customers, but if an attacker sees a vulnerability, they're going to pay for an account if that means they can attack a whole bunch of people and get a whole bunch of credit card numbers. They're going to give you, your $5 subscription and then cancel it right away. Even if they're paying customers, do not trust your users. Because you know what? You know who has access to your app, your web app on the internet? Everyone. Everyone has access to it. It's not just your legitimate users. If you have a fan site for your favorite anime, it's not just fans of that anime who are going to use that. I don't know why that popped in my head, but it's not just going to be fans of your favorite show who are going to your app. It can be literally anyone with an internet connection. So when I say never trust your users, what I'm really trying to convey here is, do you trust literally everyone, asterisk, with an internet connection? It's not literally every single human being ever, but every single person with with an internet connection, which is billions of people. Do you trust every single one of them to act in good faith? I know I sure as hell don't. I trust a lot of people, but not literally everyone. I'm not going to trust them. There's going to be somebody out there who is not trustworthy, who is going to exploit anything that they possibly can on your site, and looking for those vulnerabilities. You might say, well, I just got my little rinky-dink app here. Nobody's going to even bother attacking me, which may or may not be true. The issue with even that line of thinking is there are people who want to attack things. There are people who want to do damage or recover private information for their own use, especially like credit card numbers, social security numbers, or whatever. Any private information that's valuable that they could probably sell on the black market. I would assume most of them are doing. And then other nefarious people have a hold of it. And what some of them do is they have bots. Like, you have the technology to be able to do this right now even. Have bots that just go through every IP address and look for common vulnerabilities. They're going to look for things. I actually had one of these. I had MongoDB, a database that I accidentally exposed to the world, and all my data was deleted. And there was a nice little note in the database for me that said, send Bitcoin to this person if you want to recover your data, or else we're deleting it after a few days. Like, they're just scanning for common vulnerabilities, and they'll eventually find you. Even my rinky-dinky site, it was just an example for a class. Luckily, it had nothing private associated with it. It was just an example I was using for a class that I happened to deploy with a domain name. And yeah, they scanned, found my vulnerability. I said, man, I'm dumb for having that vulnerability in the first place. But it was a good lesson that I can use in lectures too. It wasn't, my first thought was, well, it's hosted at UB, they're attacking UB. No, it was hosted at my DigitalOcean account. It was just a DigitalOcean IP address. I don't trust literally everyone, and neither should you. You will get attacked if you have a vulnerability. It's just a matter of time. So HTML injection attacks, let's talk about what this is specifically. If somebody in chat decides to not just say chat messages, they decide to type something like this into chat. And your page is going to render that in the HTML of every single user. If they can get JavaScript, their JavaScript running for every single user who uses your site, there's almost no limit to what they can do. Probably the simplest, almost funniest attack, I don't know about funniest, but you can have some script that redirects them to a different page. And then as soon as your page loads, they get redirected to some attack site, and now they get all your traffic and all your users. And if they make that attack site look like your site, and it says, please log in again, you've been logged out. You got username and password for a lot of users. Anyone who falls for that, which that one would be kind of tricky to detect. Like a typical user might just fall for that one. You have to really be watching your URL and see that the URL changed to a different site and notice that. And even then, with subdomains, you can make the URL look pretty convincing. If Microsoft.support.shadylink.com is very common out there. So they type this in chat, and you just rendered that in the HTML for all of your users, and they're all compromised. That attacker just got everybody attacked. Whatever JavaScript they want to write, it just executed for every single one of your users. That's bad. Hopefully I don't have to say how bad that is. So this is an HTML injection attack. Injecting HTML itself isn't too scary. It's when they're injecting HTML that contains JavaScript. That's where it gets really scary. So we call it HTML injection attack still, but it's really when they're injecting that JavaScript. Actually, I think there's another name for it when it's JavaScript. I forget what it is. Cross-site scripting, I think, maybe. But that gets scary. This gets scary when they're injecting JavaScript because they can do a lot of things with this. So to protect against this, here's the good news. Super easy. Look, I missed a Y. This is like the one slide I added for this iteration of this, and I missed a Y right there. But lucky for us, super easy to prevent. So this is the easiest thing. The hardest thing by far of protecting against HTML injection attacks is just remembering to do it. You just got to not forget. It's something you got to do with every site, and don't forget on any values. Hopefully for your homework, I have security in big red letters all over the place, so hopefully you won't miss it. Some students still do, and I put the word security in red letters so many times that I don't feel bad about giving them zeros anymore on the objectives. Please, please don't forget to do this. At least go through the testing procedures, and when you get to that line, go, oh crap, I forgot to protect against this, and then go through and fix your code. So hardest thing is remembering, because it is hard to remember. I used to feel bad. I didn't put the red security letters and the warnings in 3 different places on the homework, in the description of the objective, the testing procedure of the objective, and the grading box, the grading rubric way at the end. If I didn't have it when I didn't have it in any of those 3 places, I did feel bad. I still gave them points off, but now I feel less bad about it. And fewer students make the mistake. Anyway, you're not going to forget on the homework, but when you get out there in industry, it is one of those things that can just slip your mind. So always watch for this one. Always make sure you're protecting against this. And here's the protection. Fits on one slide. And I could even condense it more. But we're going to escape 3 characters. That's all it takes. Ampersands, less than, and greater than. We're going to replace these 3 characters with their HTML escaped characters. Remember way back when I was talking about HTML for the first time, and I said certain Unicode characters have these shorthand escaped values, so we don't have to remember their hex values. Here's where that really comes in handy. Ampersand amp, semicolon, that's going to be the escaped HTML character for ampersand. When your browser parses your HTML and sees this sequence of characters, it's going to replace that with the literal character ampersand and not interpret it as an ampersand as a character in HTML. Same with LT and GT, less than and greater than. If it sees these escaped characters, it'll just render the symbols themselves, not interpret these as less than and greater than. And without these three symbols, hell, without just less than and greater than, try to write any valid HTML, much less a script tag that's going to start some JavaScript. Try to write anything without these two symbols. And then the ampersand, I keep meaning to look this up, but I think it's because the ampersand can be used with escaped characters. I think there's a way to abuse that and get some valid HTML out there. Maybe you ampersand the ampersand, and then, I don't remember. But these three characters, and that's it. And if you want to go above and beyond, you can escape double quotes and single quotes as well. The Python escape, HTML escape, has an option for that. For my money, these three, it's going to get the job done. Where do we see the grades? We turn in the project late. Where can we expect to see our grades? So project part 2 deadline, that's the makeup deadline for part 1. So that's when part 1 would be graded again. So a week after that one at the latest. And then you're protected. Those three characters. And you can, I mentioned it, but you can actually use, I allow on the homework, the Python html.escape method. If you want to use that one, I'm fine with it. Like, it does the same thing that I'm going to show in the code. It will do a find and replace ampersand with amp, less than with LT, greater than with GT. Which, I don't know. I don't care if you write the method yourself or use the Python built-in method. Either way, it does the same thing. And just one, on this slide. And then this becomes this, which looks janky. But when this is rendered to the browser, it'll look just like this. So it'll look like they typed this in chat, but without being interpreted as HTML. Because those less than and greater thans are being treated as the literal less than and greater than characters. The project, no, I know some of you can see the project grades are out. You should be able to see them for project part 1. I can't. None of you can? One of the TAs said they were already getting regrade requests and complaints. I'll look into that after. Maybe people are just preemptively complaining. I don't know. But yeah, I'll have to look into it. Because grades are posted on AutoLab. It's possible the TA forgot to release them, so you can't see them. I'll address that after class. Is that what happened? So maybe the TA unreleased them? I don't know. I'll see what's happening. I'll see what's happening with that. All right. And the order does matter. So kind of one little thing to note here. If you are writing your own method to escape these, the order is important. Always escape your ampersands first. Since the ampersand exists in the escaped LT and GT sequences, you'll get this if you escape ampersand last. And then you're going to get some weird stuff. You'll actually get what looks like the escaped characters in your code because you escaped the ampersand, which was part of ampersand LT. You're going to escape that. So make sure you do these in the right order. If you're escaping them yourself, ampersand needs to be escaped first, or else you're not getting what you want. Okay. Any questions? So that's really it for protection. Escape these three characters, and you're good. For your homework, that's in chat messages and usernames. Usernames are displayed to all users. So make sure you're escaping HTML in those usernames as well, because that's another vector of attack that an attacker could take advantage of. So we want to make sure that that's protected. For the usernames, this came up in office hours. I'll mention it here so everybody hears. You have to escape the HTML in your usernames, but if the usernames are kind of, if you even reject the usernames, I'd be fine with that. Usernames If you don't allow special characters in them, that's fine. If your app breaks, if it has special characters in it, that's fine. I don't care as long as an injection attack is prevented. So if you have an escaped HTML character in a username and in chat, it shows up all janky, I'm fine with that, as long as it's not of a security vulnerability, because users shouldn't be able to use special characters in their usernames anyway. So I'm fine if that functionality doesn't exist. All right, any questions on HTML injection and how to prevent against it? This is the last piece of the puzzle for all of learning objectives 1, 2, and 3 for homework 2. Yeah, homework 2. So if there are any questions about any of the learning objectives for this homework, now's the time to talk about it. On Wednesday, I'm going to go over the application objective. And Friday is, oh no, what was Friday? Examples in testing. I changed the title of it from testing APIs to examples in testing. I'm just going to do a bunch of examples. Probably some live coding and stuff. It's released and unreleased. Now I'm wondering what happened. There's probably a bunch of chat in the TA chat about what happened. Okay, if there are no questions, I'm going on with, I talked about that. I guess I'm doing these in backwards order. Bills win. I think I'm logged in. I don't want my stuff. Oh, no. There we go. All right, well, I should have known he'd between something crazy. Oh, this is a bad idea. All right, so never trust your users. Let's expand on that a little bit and do some demos of what users can do. You ever seen a fake tweet before? We've all seen fake tweets before, right? And sometimes the fake tweet is obviously photoshopped and stuff. I don't know why people do that. What we would actually do is inspect element. So anything you send to your user, all of the front end, HTML, CSS, JavaScript, multimedia, you send that to your user. When I go to twitter.com, all of that front end is downloaded on my machine. And guess what I can do with it? Anything I want. It's mine. I don't like this banner here. It's gone. I want the whole thing gone. It's gone. I don't like this tweet. Oops, I got the wrong element again. I can delete it. I can make anything, any changes I want to this front end. It's basically my copy of the front end. So if I want to, I'm done. But I want to make this a little more lecture friendly. I can change this tweet. I can take a screenshot of it and then post it somewhere. It drives me nuts when somebody does the Photoshop thing because you can make it look legit. You can change any tweet you want. Take a screenshot of it and then share it. Do whatever you want with it. Don't do that, please. But if you see, what am I trying to say? If you see a screenshot of a tweet and there's no URL, there's no link that you can click to actually go to that tweet, don't believe it. It's probably fake. I can take a screenshot of this and send it in the Discord, and some people are going to think it's real. It looks real, it looks legit, doesn't it? But your users can change anything on the front end, so they can do whatever they want with it. And let's see if we can find a. Let's see if I can quickly find a example here. I'm not logged in, so this might. Yeah, it's not going to really want me to. If I come across an example, I'll do one. But we can change anything on the front end. If there's an option that's, say, disabled, you have an option, and it doesn't let you check it. You can go into the HTML undisable it, re-enable it, and you're able to select that now. I need to find an option that's disabled for me, though. Maybe I can go into my Kong settings. Oops, not payment info. It's I'm not going to find one easily, but we can change things. So if there's, say, a drop-down list that doesn't have an option that you want, can I just find a drop-down? Is there what's a site that has a drop-down box? That's all I want. My site? Which one? CSE 312? Doesn't have a drop-down though. It has these things. These aren't really drop-downs though. I can break other stuff though here. Here, let's. Oh, I got one. So I want to go to this link. I'm going to change it to. Oh, this would have been a great segue if I planned this ahead. I'm going to change that link for Autolab. Now when I click Autolab, it's going to take me to games. I can change anything I want here. You go into the HTML and make those changes. I need a Piazza. I don't like going to Piazza in class because it has too much private information. It has all your, like when you're anonymous on Piazza, you're not anonymous to instructors. So I don't like doing that. I've accidentally doxed people before. What's your Twitter account? I think my Twitter's Jesse Hartloff, at Jesse Hartloff. I don't use it though. I need a oh, I know. Contact us. Okay. Yeah, here we go. So I have these checkboxes, and they all have values associated with them. I very briefly showed the code for a checkbox. Actually, did I? I might not have got to that one. But if not, let's talk about it now. We have a checkbox here that's going to have, no, it's not an HTML form, but right here is going to be the value, Buffalo Niagara. It has the text Buffalo Niagara community, which doesn't mean anything. That's just for us humans to know what this option is. But the value that's actually going to be sent to the server, that's Buffalo Niagara community. What's in the value, just like our text boxes, that's what's sent. That's what's sent over. So if I want an option, what is this? Your affiliation. Just my own dude. If I want to send that, now when I select this checkbox, what's actually sent to the server is just my own dude, and whoever's processing that ticket is going to be like, what the hell? That's not even an option. No, it's not an option, but I can do whatever I want with the front end. And they shouldn't trust me. They should know that I can make this change, and even though it still says Buffalo Niagara community, that's just text here. Like I can change this, but what's sent to the server is the value of that checkbox. That value is sent. So if I want to send something that I'm usually not supposed to send, not allowed to send, I want to change the value of an option and then send that option there. Or even create my own. I can create another checkbox entirely. You get the idea. It's the front end. It's my copy of the front end. I can change whatever I want. And I could do a lot of damage, but it's just my copy of the front end. This is my way where I can send requests to the server that the server might not be expecting. This is why, like, disabling, this isn't an actual HTML form. Oh, it is an actual input, though. So disabling an input, what devs will do, and what you can do for usability and UX purposes only, this is not a security thing, but you can disable the input. So if I disable, disable it, I can't click it anymore. But you can go into the HTML, find the word disabled, and enable it. If there's something disabled, you just go into the HTML, delete one word, and it's enabled again. Just because you're disabling something in your HTML does not mean your users can't access that. They can still access it. They can access options that you didn't even give them. Do not give them those options, or don't give them that power. On the server, you need to check for those things. Check for invalid inputs. If it's not one of these valid inputs, this should reject my request because they know I tampered with the front end. Or if you go a step further, I could just open up a TCP client, create a connection to the site, and write whatever HTTP request I want. HTTP request is just bytes over a TCP connection. You can send literally any request you want in any format, any way, shape, or form. You can create it just by creating a TCP connection. You don't have to even go through your browser, much less go through an app's front end. Never trust your users. They can do anything. They can send you any request that's spoofed in any way, shape, or form. But, I blew my segue here, but I'm blowing it again. Hold on. This was the last demo that I was going to do last time, so let's get this one. Here I am logged into my Congregate account. And to see this, we can go to Application. If you ever want to see your cookies, I don't think I did this in lecture. I should have. Actually, I think I did when we were talking about cookies, but hopefully I did because you needed it for homework 1 to verify things. But go to Application, and then you can see your cookies. And I can see all the cookies that Congregate happily sets for me. And I hate these things, are the way these are sized. And you can see Twitter's got their eyes on me. Is it only Twitter? Oh, wow, that's shocking. I thought it would be a lot more than that. But Twitter has their eyes on me when I go to Congregate. Probably because they have some social media, some Twitter thing. Oh, they have Facebook, too. I'm surprised Facebook isn't watching me here as well. Yeah, just Twitter. Weird. But I have all my cookies. Most notably, this Kong sec. I looked at this beforehand, so I know what cookies to look for. It takes a little looking to see which ones are the relevant ones. But I have this Kong sec, and what I can do, that's my auth token. Spoilers, by the way, that's my auth token. And what I'll do is open up a Chrome browser. Chrome isn't going to have any of my cookies set that are set in Opera. And I'll go to Congregate. You can tell I did this demo before because it's right there. Actually, I did this wrong already. I want to go in an incognito window just to prove that I'm not doing any shady stuff here, except the intentionally shady stuff. Congregate.com. And it's an incognito tab in a different browser, not just a different browser window, but a whole different browser in Chrome and Wi-Fi. You got to hold out on me here. You got to pull through. And it's not going to have any of my cookies. I won't be logged in, because their auth token will not be there. Oh my goodness. Most lectures, if I'm just doing slides, I can get through this, but today I need some Wi-Fi. While we're waiting for that, I'm going to grab this Congregate session token and look at my cookies here. And this is where my studying the app beforehand comes into play. I'm going to look at this Congregate session and replace this session. So Congregate doesn't just take your auth token. Your auth token has to be associated with a session. So I'm going to change this Congregate session. You can see I'm not logged in. And then I'm going to take, oh no, how come that loaded so fast? This Kong sec, this is my auth token that I was issued. These should have lots of entropy. We got a lot of digits here, a lot of characters here. And I don't have any Kong sec here because I'm not authenticated. I'm not logged in. So I don't have any token for that. Well, I can just add a new one. Your users can do anything. Do not trust anything. And then I hijack that cookie, I compromise my own account, steal my auth token, and now I have the appropriate auth token associated with the appropriate session. I did not type in my password at all. Wi-Fi, you're killing my timing. But I'm logged in. So without compromising username and password, with just that auth token, the server is going to say, well, everything looks legit here, and authenticate me as myself. Well, I mean, I'm hacking myself here, but authenticate me as HeartLoadJL because I had the right auth token. Why wouldn't it? That's what the server does. That's how authentication works. So we need to protect those auth tokens. They are as valuable, not quite as valuable, but almost as valuable as passwords. So they can steal that. If they can steal that token, they can log in, and from here, hopefully there's like email backups and stuff, but I can try to change the password and then lock the original user out of the account. Hopefully that says, hey, we sent you a password with your email change link, and then that prevents this attack. But potentially can do a lot of damage here. Oh my goodness, it's 37 already. So on our homework, we have this chat app. Where we can send messages. And if we're not protected against HTML5, we can type any HTML we want, and it's going to render as HTML. So I'm not protected against HTML injection attacks right now. I can put any attack that I want in here, which I happen to have a few of my favorites ready right here. So the script tag actually doesn't work the way I showed it in the slides. It made my point in the slides, but this one doesn't work because the way that we're rendering the page, if you're rendering HTML template server-side, this works. But since the way the homework's set up, it's rendering the HTML client side, and it won't run the script tag when it's rendered. But we can get around that. One way to get around that is an image. I'm going to have an image that's 1 pixel. This is actually common. It is probably how Twitter has those cookies in Congregate, if there's nothing that's more obvious that I missed. I'm going to make this 1 pixel, and I actually will give it an image so I don't get the broken image icon. And then I'm going to give it an onload attribute. This is going to be when the image loads, it's going to run this JavaScript, which is going to say, hey, you've been hacked. And then I'm going to say hi chat at the end just to make this look like a legitimate message. And I'll go in private browsing. Oh, I don't have it. Localhost 8000. I'm going to go as a separate user. And they've just ran that JavaScript on my machine in this other browser. So one user submits this, and they can attack everyone. Okay, not too nefarious quite yet. We just logged something to the console. What if I do something a little worse? I'm going to skip right to the last one because we don't have a ton of time here. So I have an auth token. It's just a fake auth token. I have... Oh my goodness. Oh my goodness. We can do this. I'm going to paste this, which has just more JavaScript.